Hey everyone, Roos here. Welcome to this special edition of the Pickup Show, the show where the algorithms are always accurate. In this episode, I'm going to show you how to do some basic iterative calculations in a spreadsheet. So, let's get started. Take notice, I'm using the LibreOffice calculator. It's an open source version of a spreadsheet. You're probably using Excel, but not to worry, the functionality is nearly identical. It just looks a slight bit different in implementing the software steps, but you should be able to follow just fine with Excel. Notice that I've already built a control panel, and the reason I call this a control panel is because I've defined these parameters. In the middle column, they're listed, and the values that the spreadsheet uses to represent these are in the adjacent. If you haven't watched the control panel video, you should probably go watch that and build the control panel, and then we can get started from this point. Notice also that I've added a label column. Well, I don't know if maybe a detailed label column. This is akin to commenting your code in a real programming language. In case somebody looks at this, they'll know exactly what I mean by x_0, v_0. Those are initial position, initial velocity, a is acceleration, etc. All right, so what we would like to do, here's our task, and we're going to use this control panel eventually to change the parameters and see how it changes the calculations. But what I would like to do is evaluate the two kinematic equations, just evaluate the functions at different times, and basically build what I like to tell my students is a kinematic problem solver. All right, and you'll see what I mean by that, but let's start by defining three columns. So I'm going to have a time column, a position column, and velocity column. We're going to keep this simple, and we'll do this for a constant acceleration. So we really don't need to have an acceleration column. It would just be a column of constant numbers. I'm kind of let's make it look neat. I like to highlight these and center everything. Just makes it look nice. You don't have to do that. Doesn't really change anything. You also might want to take time and put, time in seconds, put units in here. But let's not take time and worry about all those details at the moment. So, of course, we want to start time at 0. So what I'm going to do is populate successive boxes underneath this time column, and every successive box going down will be a later time separated by some time interval that I have yet to define. All right, so that's what I would like to do. And so we're going to start out at time 0. Initial time is 0. That's usually what we do. And what I would like to do, let's say I want these times separated by, I don't know, 2 seconds. Right? And eventually I'm going to come over here then, and I'm going to program in the position as well as the velocity kinematic equations to be evaluated at each of these successive times. So if I want the position and velocity every 2 seconds, I could just type these in. 2, 4, 6, 8. Which is not bad if you're only going to do, 10, 12, even 20. You can type 20 things pretty quickly. What if I wanted to go out to hundreds of seconds, though? I don't really want to. I mean, that's a lot of typing, isn't it? Or thousands of seconds. You're going to be typing all day. So there's a better way to do this, and let me demonstrate that. So first of all, let's go over here, and let's define a time interval. That's all this is going to be, is some time interval in seconds. The middle one here is my label, so I'm going to call it dt. Now don't get this confused with a infinitesimally small. It's not an infinitesimally small time. I could probably take time and make this an uppercase delta. Let's not do it. But just know that this is a dt. It's a delta t time interval. I'll just keep it delta t. And over here now, this is the label. Adjacent to that, I have to define it as dt. I go up to the name box, type dt again. You can see a little slower version of doing this all in the control panel video. But this is where I've defined the value of dt to be located right adjacent to its label here. And if you really want to be neat about things, you go up here and you tell it that that's the same color as the control panel. So let's say we want dt to be 2 seconds. So I enter 2 in there. Just so you know that I've got dt defined properly, let's assign this box, just chose a random box, let's let this equal dt, and it knows what it is. And I could change this and it would change this instantaneously. All right, so let's get rid of that and go back up here. Now, here's what I could do. I could do the following. This is time 0, that's the initial time. The box below is going to be one time interval later than the initial time. So this will be equal to the previous. Now look, I can just select it here. I can say, let this box be equal to the previous value, and I just selected it. You'll notice it puts a little purple box around here, and it calls it E2. That's just identifying the column and row, plus dt. All right. Now it knows what dt is. It grabs it over here and it adds 2 to the previous time. That's what that just did. All right. Now you might think, well, what have you really accomplished? If you got to type all that stuff, you may as well just type 2, 4, 6, 8 if you got to keep typing that in over and over again. Ah, I'm glad you asked. Because here's the little trick, and maybe you're familiar with this, but this makes this very, very useful to populate values iteratively. So look, I highlight what I just programmed. Once again, if you want to look at what you just programmed, it's actually up here in this field here, or you could go back to the box and do a double click and it shows you what you programmed. If you're using Excel, by the way, it not only color coordinates the box you chose in the calculation if you're using another box, but it also colors the parameter here, dt. So if you're using Excel, you should see dt as a different color than this blue one, and the background, there should at least be an outline around of that same color around where the location of the value dt is. Right? Okay, so that's what I just programmed. So hit enter. So highlight what you just programmed, and notice, look at this. Look closely. There's this little box. See that little square? Little box in the lower right hand of this cell. And when I move my arrow over it, it turns into a little skinny plus sign. I forget what it does in Excel. I think it goes from a plus sign to a fat plus sign or something like that. Anyway, as I hover over that little square like that, what I'm going to do, I'm going to left click and drag. So however you do that on your box, let's do that for a couple. Just left click, drag down a couple, and look, there's a smart iterative function that thinks it knows what you want to do, and in this case it does know what I like to do. So again, you double click to see what I programmed here, and by choosing this one and then doing this little drag down, it iterates it and it updates it by adding 2 to each successive box. In other words, every one of these boxes now is a later time by 2 seconds. So if I click on this one, for instance, you can see it used the time before and added the constant, or the name, or the variable, or parameter, whatever you want to call it, delta t equals 2 seconds. It added to the previous one each time. Right? Now, you could drag this down as far as you want. I don't quite remember the limits. I think you can actually drag this for thousands, maybe up to 1,000,000 values. I don't know necessarily why you would want to use Excel for 1,000,000 values, but you can if you want to. By the time you get to thousands and thousands of values, probably you're going to graduate to a programming language, but Excel will get you pretty darn far even if you're using thousands of values. All right, so let's say we want to go out to maybe I don't know, 1,000 iterations. Well, there's a couple ways to do this. All right, one way is to hover over again that little box, and you can just continue where you left off. Hover over the box and just drag it down and keep dragging it down. So I'm clicking the left button and I'm dragging down. I got my little cursor down at the bottom, and we've gotten 1,000 rows. You don't have to stop exactly at 1,000. I stopped at 1109. That gets us a good amount of time out here. All right, now let's use the kinematic equations to calculate position. And look at the parameter values real quick here. We've got initial position 0. So let's say even though I have it X, let's say we're going to toss something vertically. I guess we could change it to Y, but let's keep it as it is. So we're let's say I have an object I would like to toss upwards, and we'll keep it a free fall. and near the surface of the Earth, so negative 9.8 meters per second squared is the acceleration due to gravity. Of course, delta t isn't going to come into play when we are evaluating the kinematic equations over here in the position and velocity column. We're going to be using the time here, the adjacent time, to fill those in. So dt only plays the role of the interval here. But let's actually put the times a little closer together. So what I want to do, highlight this before I start programming in position and velocity column, and let's make it, I don't know, 0.1 maybe. Okay, now you notice what just happened. I changed it from 2 to 0.1. Now the successive times are only separated by 1/10 of a second. Right? So that's, again, another reason why this is called the control panel. You're controlling all the values that are used in all the calculations here by changing one parameter value in the control panel. All right, so let's use the kinematic equation, the 1/2 AT squared equation for position. All right, so let's program that in, and then I'll show you how we iterate that down to match all the values that the time has been iterated down to. So this is x underscore 0 plus v underscore 0 times, now this is important, we have to go over here and select the adjacent time. This is time, it's not delta t, all that did is give us the interval between times. I want this box here, that's the actual time at this instant of time, plus 0.5 star a times, now we got to select time again. Now one of the, you can see what's happening here. The equation is sort of the entry here for this position box that I'm programming. It's leaking over to the left as well as to the right, and so I don't know if I'm going to be able to select this. It does allow me to select it still. Sometimes it doesn't allow you to select it and you have to manually type in the location of the instantaneous value of the time. Here it actually let me select it, so it popped in E2 for me, but don't forget to raise this upward pointing arrow to the 2 power. Right, and look at that closely. Now if you're using Excel, all of this will be color coordinated for you. The X0 lettering will be changed, the color will be changed to match a box going around the location of its value. Same with V0 and the same with A. All right, so if I hit enter, of course I should get 0. I better get 0 because the time is 0 and we haven't, this is the initial position, and that's what I've wanted to start it out at 0. Right? Now, there's a couple ways you can do this. I showed you one way to do the iteration for time, the little drag down way. So you could do this if you wanted. Since we programmed this value, you could drag it down a few values and you'll see that it actually updates and uses the time in the calculation. If you wanted to click on one of these, you can see what it's using here. So it is indeed using all the parameters we defined in the control panel, and it's using the adjacent time. So that's exactly what we want this to be doing. But there's another way to do it, so let me erase those. Just hit delete, gets rid of them. So I programmed this. There's two more ways I'm going to show you how to do iterations, and you can use these whichever one your favorite one is. It does the same thing. If your column is adjacent to one you've already dragged down to some point, and let me just remind you, we've dragged this down to what is it, 1109. I just sort of randomly stopped there. Hover over, move that arrow, hover over that little box, and instead of doing a drag down, do a double click here. Ready? Double click. And it populates all the values, all the rows underneath the column, all the way down to where the adjacent column stopped. And you can see it stops at the same place, and when I get to the bottom it has the time column at 1109. So you could do it that way, or there's even another way to do it. And let me demonstrate that other way with the velocity one, maybe instead of erase all this stuff, right? So let's program the velocity, and then I'll show you yet another way to iterate it, which might be quicker, but it's not as fun as doing the double click or the drag down, in my opinion. All right, so this equals, all right, v underscore 0. Again, if you're using Excel, everything should be color coordinating between here and the values that you're using, plus a star, and now remember, I've got to grab the time here. V0 plus AT, I've got to grab this current time. Okay, and then I hit enter, right? And that does indeed match what I wanted my initial velocity to be. It should, of course. Now, here's the other way that you can do an iteration. So go over to here. So highlight the one you just programmed and go back to that name box over here. All right, and here's what I'm going to do. I'm going to go, so this is column G, and you'll notice we're starting in row 2. So I'm going to keep G2 there. I'm going to do a colon, and I think it was 1109 was the row, wasn't it? 1109. See that? G2 colon G1109. Now hit enter. There's a couple steps. So the next step is hit enter. Now you'll notice that it highlights everything from G2 all the way down here to where the other two columns left off. There at 1109. Okay, let's scroll back up. To populate that, then we have to go to, now this is where it looks a little slightly different from how you get to it in Excel, but it's the same command. I think I got to go to data, and it's called, no, maybe sheet. It's sheet, and it says under here, under the sheet, again, I don't remember what it's called in Excel, but it's the same thing. It's called fill cells, and in particular fill down. As soon as I click fill down, it populates everything according to that equation. If you want to check just to make sure, choose one. So I don't know, let's choose this one, double click on it, and you can see the equation or the formula that was used to program that it is indeed using the adjacent time. All right. So that's how you do these iterative calculations in a spreadsheet. Every one of these values under the time, under the position, under the velocity column are associated with that column, of course. They're all, the times are all separated by this delta t, and the position and velocity values are just evaluations of the kinematic equations at each current time. Right? So you can use this. Just before we close, for years I have my students build this as their, what I have them call it is their kinematic equation problem solver, or kinematic problem solver. You can solve just about any of those classic kinematic equations with this. So for instance, instead of just one time interval or one calculation at one time, you've got everything you need to know. You can even increase the time resolution here. Let's say you wanted to go to 0.01 seconds instead of 0.1. So this is the position and velocity of an object subject only to the acceleration due to gravity. We're neglecting air resistance, of course. And so if we toss whatever this is up into the air at 10 meters per second, and if it does indeed accelerate at this rate, this tells you exactly the position and the velocity at times out to the hundredths place here. You can make that 1,000th, 10,000. You can drag it down to more iterations if you want more resolution. But so for instance, at what time does the object reach its highest point and then turn around and start falling downward? Well, I'm looking at the position column, scroll down, and somewhere in here, right about there, it looks like. That looks like the maximum, so the answer is about 1.02 seconds. And you can see right at that point, it has gone from a positive velocity, and then at the next time interval, it has transitioned to a negative velocity, which means it stopped and is now falling downward beyond 1.02 seconds. If you wanted to do the same kinematic calculation on the moon, for instance, go to the control panel, change that to 1.6, negative 1.6. Now we're neglecting air resistance as exact, and you can see what would happen if you tossed an object upward at 10 meters per second straight up on the moon. Where would it be located and how fast would it be going? Just curious, what is its highest position? Remember, it was something like, oh, I've forgotten what the number was now. Anyway, it's on the moon, it goes a lot higher. I always thought it'd be fun to play hoops on the moon. Wouldn't that be cool? Get up a game of hoops. Man, it would be a dunk fest, wouldn't it? Of course, then you'd have to have a 60-foot rim or something like that. So, have we reached the max yet? Not yet. Still going up, right? Somewhere in here. Looks like somewhere in the neighborhood of 31 meters up about there, right? Hold on. Well, you get the picture. Some right about there, it looks like, right? So it took about 6.25 seconds. Um, the velocity is positive, negative on the other side. It got to about 31 meters. Okay, that's the kinematic problem solver.